turbulent 18, that Nusselt number is equal to 0.37 times the Reynolds number is to 0.6. And if number where the quantity of 0.97 plus 0.68 times the quantity of Reynolds number is to 1/2 will be multiplied into the Prandtl number multiplied by raised to 0.3. So yan, I've listed like 19 equations for the Nusselt number pala. And for Reynolds number, I think I've seen 9 equations to consider. Like if the turbulent flow is more than this number, what should be the next step and what should be these equations to consider? And what is this Prandtl number if you have this specific fluid with specific temperature, what should be this Prandtl number? Mga ganun. So there are constants to consider do sa Prandtl number, sa mga ibang dimensionless numbers natin. But we have this, I have naman tong parang tong sample problem that I've got in the internet naman. So this is a simple problem just to makita, just to see on how they are solved. So on how is this convective heat transfer problem is on ano yung kino-compute kay heat transfer convection. Ganyan. So we have here tong sample problem. Andiyan pa kayo?
Yes, sir.
Yes, sir. Buhay pa po.
Buhay pa ba? Ano yun? Gusto nyong aralin yung mga 19 equations ni Nusselt? Diba parang ng aasal sila daming equations. So we have here the next problem. Choppy. So we have here yung Nusselt ano to? Problem. Sample problem ng convective heat width of plate needed to maintain heat at a surface temperature of 30 degrees Celsius when air at a pressure 0.06 bar and a temperature of 300 degrees Celsius flows with a velocity of 10 meters per second over a flat plate of 1 meter length. So, meron tayong velocity, meron tayong pressure. So, this is a forced convection. So, meron na siyang velocity, may induced velocity na siya. So, per unit width naman to, doon conduction per unit length, ganyan siya, di ba? But may specific length dito si convective heat transfer. Meron tayo yung given air tsaka film temperature. Ayan, babalik lang din naman tayo dun sa Newton's law. Newton's law, yung equation ni Newton's law from Q is equal to HA times Ts less Tf. That if this, to get muna si film temperature, we have here si fluid temperature plus surface temperature divided by 2. So we have yung 165 degrees Celsius. 165 from 300 plus 30. So meron tayong 330 divided by 2 and then 165 degrees Celsius. So using this 165 degrees Celsius so may specific temperature na tayo, papasok tayo kay air. Kung ano ang constant doon kay air, yung properties ni air using temperature na, yung film temperature natin. So ang makukuha daw na na thermal conductivity in 165 tsaka si air, we have 0.0364 watts per meter and a Prandtl number of 0.687. So may mga tables kasi dito. And we have si viscosity na 24.6 times 10 raised to negative 6 Newton second per square meter. And then from the problem, we have yung given natin na air nga. Tapos si surface temperature na 30 degrees Celsius, fluid temperature na 300. O and then si pressure na 0.06 bar. So bar nang ginamit. And so velocity U, which is 10 meters per second, and the length of 1 meter length. Then we have to find si convective heat transfer rate. So meron tayong solution dito. Solving muna for air density. Bago makuha si Reynolds number, of course, uunahin sinasolve si Reynolds number if given na si air density. But since wala pa si air density, kino-compute muna si air density, which is equal to this equal to RT. So,
Sir, choppy ka po, sir.
Sir?
meron tayong panibagong formula. Lang. So,
Sir, mahina po ata internet mo, sir.
Yes?
Sir, mahina po ata internet connection mo, sir.
Naglalag ba?
Choppy po, sir. Kanina.
Okay na ba? Hindi pa rin, mahina pa rin ba? Nakuhan kasi eh. Ayan, sorry. Sana okay na. So, balik tayo. Okay na ba? Medyo okay na.
Okay na po, sir.
Nagbagal din. Medyo okay. So, balik tayo, no? Sa air density tayo. So, using this formula, si pressure over RT, where yung P is si 0.06 kanina na bar, where and then RT. Si R dyan is yung gas constant natin, 287.5 pero 287 na yung ginamit na lang. And then si temperature natin, si 165, si film temperature, plus 273 as what we know about Celsius to Kelvin, dinadagdag natin to 273, sometimes to 73.15, but in computing, to 73 is okay na. And then dito sa kay pressure, 0.06 times 10 raised to 5. So si bar ginawa na siyang Pascal. So Pascal na tong nasa formula na times or 0.06 times 10 raised to 5, we have 6,000. So 6,000 Pascal already. But because yung 1 bar is equal to 100,000 Pascal. So we cannot cancel si Pascal since yung gas constant natin, ang unit kay gas constant, si 287 dyan is joule per kilogram per Kelvin. So himay-himay na naman natin si units niya to cancel these units. So from Pascal, So 6,000 Pascal na yon. So from Pascal, ginawa na siyang Newton per meter square, where Pascal is equal to Newton per meter square. And then si Joule doon kay Reynolds kay gas constant, yung R dyan is Joule nga daw. So si Joule is equal to Newton meter. So to cancel na si Pascal doon. So dito sa taas we have na si Newton per square meter. To cancel si Newton, ginawang Newton meter si Joule dito sa 287. So yung